It is 2 hours UTC, and it's time again for Astronomy Daily Live. Hey, everybody, this is Cosmic, and welcome, welcome, welcome. Come on into the circle of friends where we gather every single day, pretty much every single day. Now, I cannot say 100% every single day, but close enough. Close enough. I think in the 3 months that I've been doing this, I've missed 3 days. So that's not too bad. So hope everybody's doing well. Everything is okay here. Pretty excited about Gaia data release number 2. Let's go through that a little bit tonight. Just sort of skim over a little bit, but uh, before I do, I have to. I have to. As a scientist, as a scientist, I have to. I have to talk about this this series of images that have come out the past day or so uh, with the Rosetta spacecraft and Comet 67P. The Everybody's very excited about what they're seeing, and it's it's a little disappointing, and I'm probably going to offend some here, so I guess so be it. So be it. But as a scientist, I don't try, at least I don't try to sort of take things at face value. Okay. Um, and unfortunately, what I'm seeing being done in the astronomical community is exactly that, is seeing this series of images that have been, put together into a movie, um, and it looks very impressive. And they're even calling it, a snowstorm. They're calling it a snowstorm. I got. No, I guess not. They're calling it a snowstorm on the comet. Okay. Well, uh, that comet is rock, and uh, I don't know. Now, I honestly don't know if they've found any water ice yet on the surface, or any kind of snow or anything. It's dust and rock. It's dust and rock. So, you know, first of all, calling it a snowstorm, oh, that's very public. that, that's very, um, that's what somebody who doesn't know what they're looking at might call it. Um, a dust storm, dust, um, maybe. But if you look at the now, I think that what's being done with that um, movie is awesome. The person who um, grabbed all those images and put it together. There's actually, I after I saw it yesterday, I went over to Rosetta's site and found all the images, and there's quite a few. There's I didn't uh, I didn't look at them all. I didn't even count them all. But I'm thinking that I might just download them all over the next few days, and sort of have at it as well. The one thing that I did notice about all of these images is that uh, they characterize this as raw data. Okay, raw data means that it is completely uncalibrated. Okay, so as a scientist, okay, as a scientist, I cannot draw any conclusions at all, period. None, zero. There's data there, okay? There's data, and that's all there is. It's all there is. I cannot say that I'm seeing a dust storm, a snowstorm. I can't even say, you know, I mean, there are some things I can say, right? Um, Definitely seeing the surface of the comet, right? Um, and then beyond that, it with uncalibrated raw data, it could be anything. It could be anything at all. Now, I've shown what I'm going to show you here before. Let me show you another snowstorm. Okay, let me show you another snowstorm. I'm going to, well, first I'm going to make sure that I'm running live, and I'm going to tweet. Yes, Uncle Bill, I'm going to tweet. Yay. How did I remember that? I don't know. Whoop. Let's see, I need to put a picture up. Dun, 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 dun. We'll just do that one. That's always a fun one. And tweet. And what was I going to do over here? Oh yeah, I was going to pull out my chat. Pull up the chat. Hey, Miss Lady Catherine, Bobby, Patrick Manny. Hey. Glad to see you here. Glad to see you here. All right, cool. So just saying that first of all, if you haven't seen that video yet, look for it. You should be able to find it pretty easily. Search for Rosetta 67p movie. Yeah, it's all over the place right now, and it's really, to me, it's sort of sad that a lot of astronomers are just jumping what I perceive as this huge crevasse, this huge leap into it's a snowstorm or it's a dust storm, when it on the Rosetta site, okay, on the Rosetta site itself, it says it is raw data, raw, uncalibrated data. So beyond really, saying, okay, it's probably an image of the comet, beyond that, you cannot trust anything that you see there at all. The lighting, all the activity, all of that. And it's sad. It's sad to see professional astronomers jumping to that kind of a conclusion completely. I don't know. I mean, I think what is being shown is beautiful, is intriguing, makes me really want to look at this really hard. And I think I'm going to take the time to download each and every image. I have to manually do it. They are PNG files. And there's quite a few of them. I think my guess is that the movie that was being shown is just showing a few. May not be showing the whole thing. And that's part of it. It's like, show all the data, right? Show all of it. Are there other examples of this, or is this all there is? Okay, if this is the only example, if there is similar data, right, that doesn't show this, what does that mean? Anyway, let me show you another snowstorm. okay, quote unquote, snowstorm. Now, this is from a spacecraft called IRIS. It's the, in fact, I pulled up the site here. It's called the Interface Region Imaging Spectrograph. It's an 8-inch telescope that is in a polar orbit around the Earth, and it is looking at the sun, high resolution, both imaging and spectroscopy. It's an awesome, awesome, awesome thing. But what they do is they create these movies. Now, over the internet, over this stream, it's going to be a little bit hard to maybe see the full effect. But I want you to look for the snowstorm. Okay, here we go. I'm going to press play. I've slowed this down a little bit too, but here we go. Here it comes. Did you see that snowstorm? So we're looking at the surface of the sun here, just an active region on the surface of the sun. But periodically, we see, I think there's another one that, oh, here it comes. Here it comes. You see that? I think you can see that on the live stream, at least to a certain extent. Yep, yep, yep. I'm watching it right now too. So is the IRIS spacecraft flying through a dust storm or a snowstorm? Well, if I use the non, well, if I jump to a conclusion, I can say, oh, well, yeah, that looks like a snowstorm to me. Now, this is a rather poor example, but what I'm saying is that on this comet, we really don't know what we're seeing there. We really don't know what we're seeing. Now, in this case, what you are looking at is electronic noise. The spacecraft passes through a place in space, an area in space that is called the South Atlantic anomaly, and it's a place where the inner Van Allen belt of the Earth's magnetic field sort of dips a little bit low, and so there's a lot of charged particles and a lot of electrical activity, right? And these are extremely sensitive instruments, and they're able to pick up on that. Okay, but would anyone look at these, and it's going to loop around again here. Would anyone look at this? Let's watch it again. Here it comes. Okay, now, would anyone look at that and jump to the conclusion that the spacecraft is moving through, some snow or some dust or what? Given what we know about what the spacecraft is doing, right? It's orbiting the Earth. It's all I'm saying is that, look, people, we cannot jump to that kind of a conclusion at all. We have to, I mean, when you're looking at raw, uncalibrated data, you could you it it looks that bad, right? Most raw data looks that bad. And what I'm saying is that everything that you're seeing in that little movie, right, could be an artificial artifact, right? It could be electronic noise caused by who knows what. Okay, we don't know. We don't know. To make that leap to, oh, it's a beautiful snowstorm because, hey, it's a comet and comets are dirty snowballs. Well, no, no, comets are not dirty snowballs. Comets are dusty rocks. So, hydrogen hydroxide tonight. Cheers. Hello, Dr. WD-40. Thanks for coming in. I'm just ranting and raving about jumping to conclusions about uh, uh, looking at raw, uncalibrated um, data and saying, "Oh, it's this." You know, when we first observed the planet Venus, okay, what we saw was nothing. We saw um, cloud tops. Okay, we saw cloud tops, and one of the jumps that was made was that, okay, there's clouds, therefore there's moisture. Well, if there's moisture, it must be like a jungle on the surface, right? And if there's a jungle on the surface, maybe there's dinosaurs. Maybe there's dinosaurs. So, um, and actually, in Carl Sagan's Cosmos, he actually uses this example, right? And you know, watch Carl Sagan's um, Cosmos, because he talks about, the process of science. And um, what he says there was that, okay, observation, we can't see a thing. Conclusion, dinosaurs. And what what I'm saying with this comet movie is that there's a good possibility that we're making that same leap. We're making that same leap. I don't know. See, I don't know if we can uncalibrate that data. I don't know if we can take out all the artifacts. I don't know. I don't know. Stitching together a series of um, images in a movie is is a is a great idea, right? It offers a great perspective. Um, you know, for us to be able to see things moving, that offers a perspective that just isn't there in sort of the still images. Um, but you know, in all honesty, putting together a series of images into a movie isn't really all that hard. It takes a little bit of time, right? Because you got to sit there and manually download each one. But there are programs. I use a program called FFmpeg, and FFmpeg um, is I don't know if it's available on Windows, but it's definitely a Linux thing, and it is probably one of the most powerful video audio tools that I have ever seen. It's amazing. It's absolutely amazing, and literally in 10 seconds you can take 20 images and make a movie into it. So it's not really all that hard, and I'm not downplaying the brilliance of what this person did in any way at all. What I'm sort of disappointed with is the reaction, especially amongst the pros who should, at least in my opinion, right, should know better, should keep that. It's not really even a skeptical thing. It's like, this is raw, uncalibrated data. So what are we looking at? I don't know. I don't know. Honestly, don't know. It could very well be exactly, exactly what everybody says that it is. But then again, it could not. It could be nothing at all. That could be all noise. We know that the electrical environment around comets is very, very, very complex. You can't have sand dunes on a comet without, I don't know, wind or static electricity or something, right? So I mean, all of that could be um, static electricity. I don't know. See, but I'm making a leap there too. So I'm just not going to. There's absolutely no way to know. Now it sort of looked like, um, you know, there were stars in the background, um, but you know, and I'm I'm sort of making a leap here too now. The shadowing seemed to be moving one way, and the stars seem to be moving another way. So it's really kind of weird. It's really, really weird. I don't understand all the geometries. I don't understand, the shading. I mean, maybe it can all work out, but but um, um, uh, all that information is there. So it's just a matter of actually doing real science. Okay, people are calling this citizen science. It's not citizen science. This is somebody who took the time, to grab all the images, which does take time, and patch them together um, to make a movie. That's not science. That's not science at all. So yeah. Anyway, uh, as I said, um, I seem to be, sort of the lonely voice in this matter, um, and yeah. I mean, I'm not trying to be anti or um, trying to set myself apart or anything. I'm saying that this is uncalibrated raw data. We don't know what we're seeing. We don't know what we're seeing at all. And to jump to it's a snowstorm is just irresponsible. Very irresponsible. Cheers. Hello, Heptacular Raptor. Heptacular Raptor. I've got it. I got it. Heptacular Raptor. Is that right? I think that's right. Heptacular Raptor. I like it. I like it. All right. Well, cool. Let's see. If you go over to archive.org, you will see that we have been pummeled. We have been pummeled today by Gaia Data Release 2, and I am very, very excited about this data release. I'm already thinking of some things that I want to look for, and if nothing else, these kinds of data releases with this kind of volume, right? 1.7 billion sources, um, is extraordinary, right? Unprecedented. It's never been done. Can I say that? I think so. I think this might be the largest catalog. Yeah, don't quote me on that exactly, but it's big, right? Big, 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 big. But let me uh, ruin it for you just a little tiny bit. Okay, we now know the positions of 1.7 billion stars in the Milky Way galaxy. Okay, now honestly, we do not know how many stars are in the entire galaxy. But let's just say, I think it's safe. I think it's safe to say that there are 500 billion stars in the Milky Way. Okay, so let's divide 1.7 by 500. You get 0.0034. So that's 0.034%. Okay, so we now know the positions of 0.34% of all the stars in the Milky Way galaxy. Okay, now if this was anything else, like a health study or a you know, anything else, right? Common sense would tell you that that is not statistically significant at all, at all. We cannot, and again, sorry, but we cannot draw any conclusions whatsoever. Nothing. We can't draw any conclusions whatsoever in terms of extrapolating and saying, okay, we know about, uh, you know, in excruciatingly tight detail, we know a third of a percent of what's going on. Okay, so therefore, we know everything that. Uh, well, at least we have a good sense of what's going on in the rest of the galaxy, um, and maybe other galaxies, and maybe the universe. Right? Again, we can't. Sorry, well, I can't. I can't. There are a lot of people that probably can, but but I can't. So yes, that is a big number. 1.7 billion sources we now have the positions for. I think you know, we have a lot of other information too, right? We have brightnesses, we have colors, we have radial velocities, which is um, uh, how fast these targets are moving either towards us um, um, or away from us, right? Um, and I don't know if you saw the press conference at ESA, but you know, they showed a map of the radial velocities of the reds and the blues. Just stunning, stunningly beautiful, um, and intricate and compelling, and very awesome. And it's a third of a percent of just just the stuff in our galaxy. So, you know, again, you know, to really stretch to any kind of conclusions or anything, mm, can't I can't do it. I can't do it. Um, but you know, it will be done. You know, because you know, we humans have to try, and that is the scientific process, right? Is that we make these observations and then we make a guess, right? And that's and then we create experiments to either prove those guesses right or wrong, and that sort of directs us, right? We let nature, at least how it's supposed to go, right? Is that we let nature, we let the universe sort of tell us things, and we just sort of follow that path. So anyway, I just want to put this data in perspective. Is that it really, relatively speaking, it's not really a lot. It's definitely not enough. It's definitely not enough to draw any broad conclusions about the structure of the galaxy or the evolution of stars or anything else. It's just, and that's why I keep coming back to this thing where scientists have sort of donned the hats of the high priests, right? When people have questions, they back in the Middle Ages, right? If 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 the peasantry had questions about some kind of mysterious thing going on, they'd run to the priests, right? Because the priests were educated and knowledgeable, and they had studied all of this stuff, right? And so the high priests have the answers. And today, the high priests are the scientists, and the scientists have the answers. And what I'm saying is that we scientists do not have the data. We don't have the data to really be able to draw any conclusions whatsoever. The best that we can do, and the best that I do, okay, is I can guess. I can say, okay, based on this and this and this and this and this and this, I can sort of guess. I can sort of, it's like, okay, well, maybe, right? But to have the answers, oh no, I can't, can't do it, can't do it. So anyway, very very exciting. Let's just skim through the Gaia papers, eh? Because we were just bombed with Gaia data release 2 today. So let's go over to archive.org, right? Which I think I've got it set up here. Here we go. The one thing that I did want to point out um, before I get into this, and I just, I I guess I have sort of a strange sense of humor, but there are, whoops, there are 447 co-authors on these papers. So yeah, that's a lot of co-authors. It's like, every co-author got allocated 5 words, and here's his 5 words, and here's her 5 words, and here's her 5 words, and here's his 5 words, and that's how they got these papers written. Yeah, that's pretty amazing. So yeah, lots of people involved, right? So many people involved in this. It's awesome. It is so incredibly awesome to see this, right? Now, I am not going to go through any of this at all in any kind of detail whatsoever. But let's just sort of skim some of these. There's actually quite a few papers that came out today on data release 2. So let's just take a look at a couple of them here. So here's a list of the authors. It's like a Patreon list, Oh, that's pretty impressive. Let's see. Let's just dive in here. So we present the second intermediate Gaia data release, which is based on data collected during the first 22 months. I think there was something that caught my eye. I don't know if it was here. Yeah, I'm not going to be able to find it now, of course. Um, let's see. Let's just go through it here. Data processing, celestial reference frame. Yeah, so 1.692 billion sources. 14,099 asteroids. Contents, astrometric data set. There was something in here that caught my eye. I don't remember which paper it was. If it was this, maybe it was the photometry one. Yeah, maybe it was the photometry one. To planet axis, the sample sources, variability information. Yeah, okay. Well, here, let's just let's go through here. Miss Lady Catherine, are you snoring during my rant? Shame on you. Shame on you. I don't blame you. I'd like to see the actual raw data. Apparently, these images are uh, created, based on the measurements, not on the actual like images. Oh, that's what it was. It was the data volume. Yeah, it's how much data was coming down to process. Do they talk about that here? No, I think they talk about that in the photometry one. So let's go over to the photometry one. Let's just go through all of them here, right? So this is just the summary of the contents. Then they do the astrometry. Come on. The machine is being slow. There we go. Processing of the yeah, here it is. So they say the second Gaia data release is based on 22 months of mission data with an average of zero point 0.9 billion individual CCD observations per day. So 900 million observations. I don't know exactly what they're characterizing as an observation. It's probably not an image, right? Uh, um, but uh, um, but yeah, so they're having to process 900 million observations a day in terms of photometry. So that's impressive. That's a shitload of data for sure, for sure. And look, this is nothing. This is nothing compared to what LSST is going to produce. Um, LSST is going to be so overwhelming that I mean it's going to be unbelievable, unbelievable. Let's see. So photometry. Uh, so they have a spectrometer to measure radial velocity. Then they have a catalog of radial velocities, processing the spectroscopic data. Um, so about 7 million bright late type stars. That's cool. Properties and validation of the radial velocities. So summary of the variabilities. So yeah, they're looking at variable stars as well. First stellar parameters from APSIS. I don't know what APSIS is. What is APSIS? Does it say in the It doesn't say what it is in the abstract here. Let's see what abscess is. I don't know. I don't know if I ever. That name rings a bell, but I can't. When is Gilles not tuning around on shortwave? I don't know. I think that's just what he does, right? Where is abscess? Abscess. Looking for abscess. Right? Isn't that what it says at the top? From abscess. Okay, what is abscess? I don't know. 3-band photometry and parallaxes. Chambers. Okay, so Priam and Flame are part of a larger astrophysical parameter inference system in the GAIA data processing. So I guess abscess is sort of the pipeline processing. I guess that's the first reference to abscess that I can see. We're gonna have to find out a little bit more about abscess, because yeah, they're not talking about it. They're not saying anything about what abscess is. Erg. As I said, this is not, this live stream is not intended to be an educational live stream. This is you and I going along, looking at this stuff together. So I certainly do not have answers. If anything, I've got question after question after question after question. So yeah, it looks like abscess has to do with pipeline processing of this data itself. That's sort of what I'm inferring from all of that. So yeah, lots of good papers, just sort of general thing. This is probably an interesting one. Catalog validation. So data release 2 contains very precise astrometric and photometric properties for more than 1 billion sources. Before the catalog publication, these data have undergone dedicated validation processes. The goal of this paper is to describe the validation results in terms of completeness, accuracy, and precision. So this I would say is where the shit hits the fan, right? Again, you can look at those beautiful images and you can look at that fantastic data, and it can all, this paper right here could say that half of it is crap, right? I don't think it's going to, but this is where the rubber meets the road, right? Right there. It is shown. Let's see. Although the astrometric, photometric, and spectroscopic data are of unprecedented quality and quantity, it is shown that the data cannot be used without a dedicated attention to the limitations described here. A particular emphasis is put on the caveats for statistical use of the data in scientific exploitation. And this is just my guess, but I'll bet you that they are going to say something like, look, we're not looking at enough data. Yeah. Thanks, Miss Lady. Catherine, I think that's that's right. That's sort of the conclusion that I came to as well in terms of what abscess is. We'll have to dive into that a little bit more, but yeah. So this is the kind of stuff that I like to look at really first. It's like, how good is the data, right? How good is it? Um, I think what I want to do, well, let's just sort of skim here. Data and general validation test. Okay, so they're going to describe how they validate the data. All right, blah 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 blah. High profile motion stars, astrometric quality. Um, Small scale systematic map of median parallaxes in a 10-degree field. Yeah, kind of interesting. You're looking at a lot of systematic weirdness stuff. Look at that. Ah, that's amazing. Let's see, large scale systematics. Summary of the comparison between GAIA parallaxes and the external catalogs. Slight differences, right? Slight differences. That's okay. Managing systematics. This is a long paper too. All these papers here are like 20 plus pages long. So a hell of a lot of effort has gone into this. Just amazing. Just an insane amount of work. Hats off just for the work done. Holy moly. Photometric quality. I like it, man. I like it when we scientists can lay it out, right? Just lay it out and tell it like it is. And you know, the pictures are fine. They make for an impressive, you know, press conference and PR and all that. But this is where the rubber meets the road for sure. I like it. Let's see. I want to get to their conclusions. That's sort of where I'm going here. Let's see, extinction and reddening. Da, 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 da. Where's their conclusions? Solar system objects, good, good, good. Yeah. Orbit determination, that's nice. That's nice. Okay, conclusions and recommendations. Let's just run through these. There's not too many. Okay. In applications, let's zoom in so you can all see it here. Okay. So in applications requiring the cleanest possible data set, spurious solutions need to be filtered. Because only a single star model has been used and calibrations are suboptimal, the quality indicators of the solutions may be used to discard other potential outliers. In terms of astrometric systematics, correcting individual parallaxes for the global parallax 0 point is discouraged. For applications where the 0 point matters, however, and if the samples are well distributed over the sky in color and in magnitude, parallaxes may need to be um, corrected from or solved for the global 0 point. In the special case of samples in small or intermediate regions, the contribution of systematics to the air budget has to be taken into account. Some substantial underestimation of the formal uncertainties has to be taken into account. For example, when doing sample selections based on astrometric precision. Whoop, just lost my page. Or for likelihood methods, reweighting the most precise uncertainties using equation A6, blah, 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 may be used, may be useful for G magnitude stars between 13 and 15, or more generally when that equals 0. The full covariance information between astrometric parameters should always be taken into account. Concerning the photometry, the color of faint stars in the neighborhood of bright stars or contaminated in dense regions should be taken with care, right? So, yeah, ultimately, Gaia Data Release 2 is a database, right? It's a searchable database. If you know the SQL language, you can create a query and you can extract any information that you want. That's what data mining is, right? Is creating a database query to extract information. And a lot of the queries can be extremely complex, extremely complex. Let's say for the astrophysical parameters, the extinctions cannot easily be used individually due to their large uncertainties. When trying to obtain an average sample value, it's important to follow the maximum um, likelihood method proposed to derive the most probable value. Blah, blah, blah. Concerning temperatures and radii, it is preferable to use them in low extinction regions to avoid biases. In summary, the wealth of data provided by Gaia Data Release 2 will represent beyond any doubt a hallmark in the history of the astronomical catalogs. However, completely avoiding mistakes and shortcomings in the astrometric, photometric, spectroscopic, or classification data in the 1.7 billion sources catalog with many intricate data for each was an impossible task given the short time since the observations were made. They took 2 years to process all of this. So yeah, data cannot be used blindly. The data cannot be used blindly, and any serious scientific exploitation of the Gaia data must understand and take into account the various limitations and caveats attached to the various Gaia Data Release 2 catalog content. Thank you, Gaia people. So that's exactly what I was just saying about, this comet thing, right? It's like you cannot use this information blindly, and that's what's happening. So 3 cheers to Gaia. It's just awesome, 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 and it's Miss Lady Catherine. It is such an insane amount of time and effort. It's unbelievable, unbelievable amount of work, and it's just un you know for me, it's an unimaginable, right? There are 400 plus people working on this. Probably not full time, but I would, you've got to say maybe at least half time, right? So you've got several hundred people working on this full time for years, right? It's just insane. It's just an insane amount of work. And then to have to write these papers and make these plots, right? Compile all this data, and you got to make sure that it's right. And it's just insane. It's I admire this kind of work so much. It gives me goosebumps, right? Because it's just so awesome. It's so awesome, to see this kind of awesome work. Um, let's see, using Gaia parallaxes. It keeps going. HR diagrams. As I said, they did this huge Gaia dump today. My poor machine is getting really slow. Observations of solar system objects. So all these papers, right, are freely available. Go to archive.org. It's ARXIV. That X uh, is like the Greek letter chi, which which looks like an X. So you call it archive.org. Thought that was pretty clever. Kinematics of disk, kinematics of the globular clusters, variable stars. Then it peters out for a little bit, but then it comes back. I think there's a couple other GAIA papers in here, if I remember right. Yeah, GAIA, stellar populations, and the distance scale. So yeah, some good stuff. I've downloaded all of these, and it's going to take me weeks to read through all those, weeks and weeks and weeks to read them. Because yeah, you've got to understand them a little bit too. It's just crazy. Let's see. I'm going to try to stop sharing the screen if I can, because I think I'm going to get out of here. I think I've created enough damage for tonight. for for tonight. What I'm saying is that, look, we have to remain skeptical but open-minded, right? So I am not throwing out anything at all, because I don't want to close any doors at all. But I think we also have to keep our skepticism very, very high, and don't fall for you know uh, things that you see and hear, because we don't know. um, we have to make sure that we understand what is going into creating the data that we're seeing, right? And if we don't know what that is, then we have to be skeptical of what we're seeing. I I It would be very, very, very cool if um, that movie of the comet was exactly as it shows. But I don't know. I honestly don't know. I honestly don't know. But as a piece of artwork, yeah, it's pretty awesome. It's very, very awesome. But that's all it is at this point. It's not anything more than yeah, just a piece of art at this point. All right, I am going to get out of here. As Uncle Bill says, bang that button that is like this. Now look, you can bang that button too, because at this point in the life of this live stream, in the life of this daily live stream, I am much more interested in any reaction at all. So if you have a negative reaction, that is perfectly fine with me. If you have a positive reaction, that is perfectly fine with me. Mathematically speaking, I'm interested in the absolute value, right? In the absolute value. So whatever it is, thumbs up, thumbs down. Make sure to share this around too. I'm always my thing is that I want to get better and better and better every single day, and I'm getting a lot of practice. I'm getting a lot of practice every day, having a great time, and yeah, you know, communications is part of it. As I said, I'm not doing this to communicate science. I am not a science communicator. I'm a scientist, and what I'm doing is I am sharing my passion with you. That's that's it. That's it. Um, if I communicate, cool. If um, um, education is occurring, cool, very, very cool. But that is sort of a secondary thing. My big thing is, let's gather together, right? Sit around, sit in our comfy chairs, with our beverage or consumable of choice, whatever it is, right? We sit around and we just gab about all things astronomical, and that's it. That's it. Have a good time, enjoy, relax, chill, have, you know, consume 10 to the 27th of these molecules in a couple of gulps. It's awesome. And, if you want educational content, you can definitely find it. You can definitely find it. That's not my motivation at all. As I said, the education will happen. Um, but I'm not trying to educate you whatsoever. I'm just sharing. I'm sharing a passion. I have a lot of passion to give away, right? And I like to give. If I could give everything I have um, to others, I would. I would, because having stuff is a huge responsibility, right? You got to take care of things. You got to carry shit around. It's a pain. It's a pain. It's a lot easier just to let others have all that. Unfortunately, we have to live a little bit, so you got to have a little bit of stuff around. So I guess I don't mind, lugging a little bit of stuff around like that. All right, I am going to get out of here. I am definitely going to keep streaming every single day, 2 hours UTC. We go for about an hour, hourish, sometimes maybe a little bit less, sometimes a little bit more, depends on what the topic is, how much I want to gab, what kind of conversations are happening in the chat. Thank you, everybody in the chat. I've been watching the conversation over there. I think that's really, really great. I am getting uh, more views, more viewers. So I think that's great too. Again, that's not really motivating me. That's a secondary thing. As I said, my thing is share the passion, because this universe is awesome. It is so awesome. And we are awesome. And we're, you know, so much a part of it. And it's so ridiculous to see us, fighting over things and keeping ourselves down. It sucks. It really, really sucks when I know that we can do so much better. We can do so much better. Our access to energy, to material, to all of that is unlimited, right? Now, it's not infinite, right? Probably not, probably not. But relatively speaking, we can literally have all the energy we need and all the stuff that we would ever want. So just, you know, if you think about that, then you don't have to worry about that kind of stuff anymore, right? You can worry about other things like going, wow, wow, isn't that awesome? You know, isn't that awesome? So, all right, I'm going to get out of here for now. Peace. Cheers. Don't get dizzy, right? We're spinning 1,000 right now, just by you sitting right there or standing right there, you are spinning on this planet at about 1,000 miles an hour, right? So don't get dizzy. Don't get dizzy. It's pretty smooth. Hold on to your hats. That'll help a little bit. All right, I'm going to get out of here, and peace, cheers. I will see you on the spin tomorrow. All right, take care. Bye.